Thanks for coming. My name is Tim Mangan. I'm from Team Urgent Technologies. Our company deals primarily with the Microsoft AppV product, do a lot of training, consulting, stuff like that. With me?
I'm his son, Patrick. I also work in his company offering a AppV sequencing service.
All right, so today what I thought we would do is spend some time taking a look at debugging in an AppV environment. And quite frankly, a lot of the stuff that we'll talk about is relative to dealing with application problems and dealing with vendors that you bring in that are doing different things to the Windows file system. All of that stuff kind of comes into play today. Try to show you the techniques that we use. We're okay? Okay. Try to show you some of the techniques that we use and some things that we've figured out as to how to do a little deeper debugging into what's going on into the operating system. Get next. Okay. So when Microsoft released AppV 5, they changed the kind of errors that we get. We used to get these errors that look like the number down in the blue there. You know, we get an 04 dash something or other, and I have a program I actually wrote, the Silverlight program up on my website that people use to try to figure out what the heck those errors are. And they were always pretty cryptic. And in AppV 5, they changed all that. We get different looking error numbers. They look like the thing we see there in the red. Go ahead and click next. But what's important on those is that we really want to just look at the last 5 digits, because those error codes are going to be standard Windows error codes. So we can look them up and figure out somewhat what's going on the basis of that part of the error codes. And even in AppV 4.6, a lot of the error codes, the very end piece, were actually standard Windows error codes. They weren't very good at maintaining that relationship of following those standards, but in AppV 5, they've tried to do that. So whenever I get one of those errors, the first thing I do is I go to Google and I type in Windows error codes. And one of the first 3 links always up there is one of these pages here, which will be the system error codes broken down by error number. So I'll go in there, find the right range there, and then I always want to remember that this is in hex, so I need to look at the hex numbers over there. In this case, we're looking at something that is a path not found. Right? A lot of errors are going to be path not found, they're going to be file not found, or they're going to be authentication errors. Right? Just knowing that much information itself helps me understand where the problem might be a little bit better and what I should be looking for in the rest of my debugging. So I always want to start here. All right, go ahead and hit next. Now in AppV 5, Microsoft has changed. So in AppV 4 originally, and with the old SoftGrid product, errors went out to a text-based log file. And in AppV 4.6, Microsoft added logging into the Windows event logs. And on AppV 5, they've taken that a step further. They've gotten rid of the text-based log file, and everything goes into the Windows event logs. But it doesn't go into the standard window logs. In the past, they would mean the Windows logs in the applications areas where we would find them. In AppV 5, they're doing custom logging. So we go down to the applications and services logs, open up Microsoft, we'll see there's a new AppV folder in there, and under there we'll have client, we'll get these 3 logs. Go ahead and click next. The first of the logs is the admin log. The admin log catches most of the AppV errors. That's primarily what you'll find in there. So that's kind of the most important one. The second one is the operational log. That'll have a lot of information about what the client was trying to do. So we'll see entries in there for I'm starting the job of doing the publishing, or I'm doing what it calls configuration, which is applying the dynamic configuration files, the deployment config and user config files. And there's a third log called virtual applications. Patrick, have you ever seen anything show up in virtual application log?
No.
Okay, neither have I. I don't know what that log is doing there. I'm assuming that the developers can turn on some secret debug stuff that we haven't figured out yet to be able to get stuff in there. But that one seems to stay empty all the time. Okay, let's hit next. Then we have the secret debug logs, the ones we do know about, which we can enable. There is a huge list of AppV specific debug logs. So each different part of the AppV client and kernel is in here. Like I'm seeing subsystem shortcuts, subsystems software client. That's about the publishing part for software clients like email clients. One for the SPAD, for virtual com, virtual fonts. They all have their own little debug logs. Normally, those logs have nothing being written to them. Okay? But we can enable and turn them on and gain some extra information. Go ahead and hit next. What do we do? Okay, first I described this. So event logs in Windows are dealing with what Microsoft calls event tracing for Windows. And they encourage developers, and especially their own developers, to write a lot of crap out in these ETW logs. Now, it's a fairly efficient process. When the application wants to write something out, go ahead and click, and click again. The application will allocate a user mode buffer, write what it wants in there, and make the call that, hey, I want to log this thing. That'll pop down into the kernel. A memory copy will get made into kernel memory, and it'll get placed in a queue for this event task thread, which is one of the kernel threads that's sitting there. And eventually, that thread will wake up and start processing any events that have been pushed into it. That'll always happen every time the developer writes one of these out. What will happen if nobody is registered for listening, go ahead and click next. If nobody is listening for that particular kind of event, it just gets thrown away. But if somebody has registered, they'll receive that event. So in the case of most of the events that we see in the event viewer, when you boot your operating system up, Windows automatically registers to receive a whole slew of events and designates the log files that they're supposed to go to. So when the event trace thread wakes up, it then writes that stuff out. But it's kind of a background operation that's happening, very low impact when they write. But what we find in Windows is that Windows is littered with tons and tons of events that are being written out, and they're primarily coming to this event trace thread and then just being discarded. So they have very low impact on the system. And the AppV client is doing that as well. And that's what those secret debug logs are, is we can turn those on and now start capturing that additional information. Hit next. Go into the demo. Okay, let's go to the demo. We got lots of demos here. Okay, so we're going to go to an AppV client system that we have here. And we'll start by taking a look at the Windows event logs and the debug logs. Let's go to the event viewer, Patrick. Okay, and we're running with the AppV5 SP2 beta on this particular system. So here we can see our AppV logs, and before we took the snapshot, we just kind of cleared out all the old junk, so we don't have anything here right now. But those are the 3 logs that we talked about. Now, when we want to view the additional logs that are available to us, we go up to the menu, and it's either view or action. Yep, in view, and that's a checkbox, show analytic and debug logs. All that did, that operation, is it made those logs visible here. So all those AppV debug logs are now visible. They're still not enabled. Nothing is registered to receive things yet, but they're there. And if you continue to scroll down, Patrick, we'll see all of the rest of them in Windows that are now available. If he opens up the Windows folder, there's a ton of other debug logs that got put in there too. So it's not just AppV. Okay. So we did that. So next, why don't we go to the EPI Manage tool. So EPI Manage is a tool that I use as my primary thing. As soon as I've finished sequencing a package, I bring it to a client machine, and I use this tool first to bring the package into the client, to add it in and publish it, and then I can use it to do my first level of debugging of this package if there are any problems. So we bring it in. If you hit the Tool Config tab, Patrick, on the far right, the one thing that we need to do in the tool when we set it up is just set up a share of where it can find the AppV packages. And now anytime I come to the tool, it'll just give me the list of packages on that first tab and then show me which ones I've already published or not. If you go to the Client Config tab, we'll see the configuration of the client. I usually do two things on this system. The first one is I enable package scripts, because that's off by default. So if I add any scripts into my deployment config files, if I don't turn that feature on, when I try to publish the app, I'll get an error. So I always want to remember to turn that on. And because I'm running an AppV client kind of in a data center, even though it's my laptop, I'll always enable the shared content store mode. It just creates fewer writes to the hard disks. So like when you're adding a package into streaming, it's streaming directly from disk into memory and not writing it back out to the VM disk again, which is unnecessary. Right? So it's a little more efficient. Also removes a lot of traces of stuff that I don't want to be looking through when I start looking at traces by removing those writes. OK, so now if we go to the publishing tab, let's just grab a package. We'll add it in. Let me take ATM. That's a good one. We'll add the package and then publish it. And you could publish globally or to the user there. And then we can try to run that application. There we go. Got our shortcut. And woohoo, we had success. OK, so that package worked just great. Sometimes they don't work so great, though. Sometimes we have a problem. We'll see some problems as we go through. One of the first things I do when I have a problem is I go to the Debug tab. Debug packages. Sorry. And here, after we pick our package, we've got a number of things. So in AppV4, if we wanted to get inside the virtual environment, a long time ago, we would make a copy of the OSD file and do some edits and then launch that thing. And then after a while, they gave us a new parameter, and so we would just copy the shortcut and add a /exe command prompt, and it would launch a command prompt inside the virtual environment. Well, in AppV5, we've got all this great PowerShell stuff, which is basically what this tool is doing under the covers. And we can just click on ask for a command prompt inside the virtual environment of that package, a Windows Explorer, regedit, look at the services monitor. And if I have Procmon installed on the system, you can launch Procmon as well. OK. Hit that command prompt again. So wait, we're there. We got time. AppV5, if you haven't worked with AppV5, it's a little bit different. OK? Everything isn't as hidden away in, we don't have the Q drive anymore. Everything actually ends up getting mounted under program data, AppV, and a set of GUIDs, which is the package GUID and the package version GUID. And then we'll see a root folder. And that's kind of the base of where the package gets put. When you have an executable there, we have the shortcut. In fact, Patrick, why don't you go down to the Start menu, right-click on the ATM shortcut, and ask for Properties. We can actually see that the command is actually the atm.exe. It's no longer a launcher process. So it's a little bit different environment in 5.0. All right, why don't we move on so we don't get too far behind. All right, we did that, we did that. We were supposed to look at the event logs, right? So we can look at that in this tool as well. If he goes to the event viewer, and when you hit the refresh events button there, make sure we got the latest, we can see we got something a little bit more in there. In that case, it went into the operational log. We didn't have any errors, so there's nothing in the client log. But we do see that there was a request to start streaming on that package. For the debug logs, we'll go to the next tab. And here, we're enumerating out the logs. And rather than what I would have to do in the event viewer, I could go to each individual log and enable the ones that I want. We can do that here, but Patrick can also right-click and say, enable all the logs. Okay? Now, it says enable and clear because that's the only functionality Microsoft gives us programmatically. When we enable it, we have to clear out any old results. But that just turns them all on. Now I could run my test, and then he could right-click. And of course, we didn't have it on, so there won't be anything here, but he could right-click and read those logs. And it'll read all of the logs and sort the data in by timestamp so that we get a good view of what happened there. OK, let's go back to the slides. OK, so I got to look around the room. Kevin's not here. Oh, that's too bad. I really wanted Kevin Goodman to be here for this, because we're going to talk about what is, your best friend when you're trying to do any Windows debugging. And we have to pay homage to this guy. Click. Mark Russinovich. If Kevin Goodman were here, yes, he'd be going, Mark Russinovich. That's why I wanted him here. Of course, he developed a lot of great tools through the sysinternals, but Process Monitor has really been my number one screwdriver to go to when I have problems, and I use that an awful lot in the app debugging. Let's go ahead and hit next. Okay. So what we're going to do is we're going to take a look at an issue that I ran into in working a package. We sequenced the package, tested it out, it worked great. Put it into production, nobody got the app. We went and we looked in the AppV error logs, didn't find any errors. Couldn't figure it out. Turned out that there was a difference. When we did the testing, we published to the user. And when we published to the machine instead, using the -global flag and the PowerShell interface, it would generate an error if you happen to be looking for the error. But the AppV management system didn't report the error at all. It didn't end up in the event log. In fact, the fact that you even tried to add this package in didn't end up in the event log. So we thought there was something wrong with the publishing end of it in getting the information down there. If we had done this through Config Manager, we would have seen the same behavior. That's the problem that we're going to debug, and it actually was that 003 error that we saw on the screen earlier. So let's go ahead and go back to the VM, and we'll go ahead and bring that package in. It's called Sigil. And Sigil is basically an EPUB editor package. Right. All right, so let's grab Sigil, we'll add it in, and if he publishes globally, this console sees the error because it's using the PowerShell interface underneath, so it actually brings this error out to us. And basically it's saying, hey, you had an error. Okay, it really doesn't provide me much information other than it gives me that hint, go check the AppV client log for more detail. Well, let's do that, Patrick. Right?
Should I do it through the...
Yeah, do it through there. Start with the event viewer, hit the refresh. Okay. So we do have a new item up there, a request for the file. Yeah. So just take the whole window left and then grab the column and drag it out a little bit so we can see some more. I want to fix that interface. I want that to go multi-line so I don't have to do this. Okay, so it's giving me the process ID. Oh, that was really helpful. Okay, and all it's basically telling me is it was attempting to do the publishing as an alternate user. And what that really means is that I'm logged in under my account, and it actually has to do this work under the system account rather than instead. When we're publishing globally, we're affecting all users, right? In fact, if you notice, when we launched the tool, we got a little elevation prompt. I do a pre-elevation just to take care of it so you don't get hit a whole bunch of times. All right, so that's all the information we got. Let's go to the debug logs. Okay, so we did enable them, and right-click and ask for all. Okay, so there is a bunch of activity that is in there, at least in the debug logs, but there are no errors. There's nothing there that really gives me a good clue as to exactly what the problem is. So, this is kind of my first level, right? I start, I try, I look for errors, I make sure I check the event logs. At that point, if I don't know what's going on, I have to go a level deeper. Okay, let's go back and hit the slide. All right.
Tim, how can you tell there are no errors?
Oh, I'm just telling him. I read them all. That's how I can tell there's no errors. If something was actually registered as an error code, it actually would have shown up as red instead of white on the list. That's, we use the level thing to help figure some of that out. Oh, we're actually supposed to go into Process Monitor on that one. So let's go do that. Okay. So with that before, what we had been doing in the past was that we would, if we wanted to do process monitor, we had a process that we went through to do it properly, to get process monitor to monitor the apps the way we wanted it to. And that would include rebooting the system, starting up process monitor once, shutting it down, that would get the driver in place, and then we would go into the virtual environment and run process monitor. And that would get the logging to be happening at the right level for us. We don't really need to do that anymore in App v5 and the latest versions of process monitor. So we can just start it anytime we want. Now when I start process monitor up, did we already go past the filters? Bring up the filters. Right? Filters is an important part of process monitor. And you want to be able to get rid of the stuff you don't want to see in terms of activity. This is the stuff that I've kind of come to. And typically what I end up doing is, I start process monitor up, and you'll see some traces start showing up. So you'll get, search host and all of these other things that you see I've excluded here will just start happening. You just kind of, when they happen, you'll see the entry. And when we get to one here, Patrick can show you, you can right click and just say disable anything that has a process name of that particular name, right? Spool SV. Maybe I don't want those. Yeah, let's go ahead and exclude that. We don't need spool SV, right? And it just adds it into the filter list. So anything from that process will be ignored. Once I get a fairly stable system, I'm not getting a whole ton of new things, then I'm probably ready to go and do my tests. So I'll start by first clearing out anything that it has captured there with the eraser, and then I'll run my tests. So let's go back with let's do this from the PowerShell, because we haven't done that, right? Let's go to the PowerShell interface. So we'll do the same thing that we tried from the tool, but show you the problem from here. So we're going to need the GUID, so let's do the git. So there's a git appv client application, which will get the information from the package that's already added to the system, because all we need to do is the publish. And now he'll do a publish dash appv client package. To do the publish to the machine rather than the user, we add a dash global flag. And then he's going to do dash package. I think it's ID. I don't know. He can just do dash PK and then hit tab and you get a tab complete on these things. I love PowerShell. And a space, and then copy that, paste it in. You need to add your space back in. Okay, and another space and dash version ID, thank you, yep. And we'll get the version on there. Okay, right click, and go ahead and hit return. Hello. Oh, that's the ATM. Really? That package wasn't left behind. Okay. So I guess you can do the add-appv client package instead. Oh, you didn't get the right one. Okay. For a publish, I think you have to use the GUID. Because you might have had more than one version added in, so when you do the publish, you got to get the specific one. Right. Okay, so great. So we generate our error. Typically, what I want to do is I want to do that eraser and then run the thing that's going to generate the error and immediately go and stop capture on Procmon, so I limit how much I'm capturing there. We're a little slow on that, but let's get the Procmon and do that now. Okay, and we stop capturing there. Now, remember we did all that filtering. The filtering only affects what's being displayed. It actually captured everything, so we haven't lost anything by filtering. One of the filters I see a lot of people put in to start with is they actually filter out anything with a result code of success. I don't like to do that. With an application problem, I usually prefer to leave successes in to give me a feel for what the application was trying to do at that point. So what I do instead is I use the highlight feature. So if you go to Filter, Highlight, and yeah, just get that one off because it remembered them from before. And then I just have those highlighted, so it's the things that aren't highlighted that I'm probably more interested in. And I find that sufficient enough. Some of the things that we'll see in here that we always want to ignore, I don't see any buffers in here. You know what? You're catching only, we're a little overly filtered, Patrick. Let's look at the filter list. I think we got to get rid of one of the green check boxes. No? Huh. Okay. It's interesting. Okay, let's just go back then. Usually I'll see a buffer overflow in a list on these. Oh, we didn't launch an application. That's probably why. This was all the PowerShell stuff, right? So when an application runs, it wants to call something that's going to get a variable set of information back from the API it's calling. And so it doesn't know how big of a buffer it needs. So usually the application will just give it a 0-byte buffer. And so the API will return something that says buffer too small. But in the return, it provides it the size of the buffer it really needs. So then the application then allocates that amount of memory and calls it again. So I always just ignore the buffer overflows. Those aren't badly written programs. That's the way it's supposed to work. Another one I'll see in here a lot of times is fast I/O disallowed. You can always ignore those. That probably should be in the standard default list. I don't know why they don't include that one. They include a lot of the other fast I/Os, but not that one. That's an artifact of the way the Windows caching system works. It's just the file system tries to do things in a fast way, and if it can't, then it has to go the slow path. That's all that means. All right, so often with something like this, I'm trying to find where the error occurred and then work my way backwards from there. All right, we'll do a little bit more of that later on. This particular problem here, I end up finding through Procmon, and it wasn't easy as well. It turns out that the issue was there is a registry entry that's used in the publishing process for this package, and the registry entry could be a registry string, or it could be a reg binary with a multi-byte string in it. And the multi-byte binary string in this package didn't have the null termination at the end. And the reason that it worked in the user case and not the global case is that apparently the part of the app-v code that's dealing with that thing in the user case noticed that there was no null there and dealt with it. And in the case of the global case, it didn't, and they had an exception, and then everything just kind of backed out. Now, why that case didn't write anything into the app-v error log when it actively noticed there was a problem and backed out everything that it had done in publishing so far, I don't quite understand. But we actually discovered not only an app-v bug that we reported into them, but the fact that they really do have different code for these different scenarios. Okay, let's go back to the slide. Yeah, how are we doing on time? Go ahead, next. Okay, let's talk a little bit about how filter drivers and things like that work. So app-v and a lot of other systems that want to hook into to take a look at what's happening on the file system and potentially make changes, or in the registry case. Back when we wrote the product originally, we used what was called hooking, which is basically inside the kernel, there was a function that would end up getting called when we wanted to read from the registry or do something with the file system, be a different one. And every function always starts out the same way when you look at the actual assembler instructions or machine level instructions. And the first command is always to save off the existing registers. So we know the size of that command, and in terms of how many bytes it is, we know exactly what it's going to contain. And in a hooking method, click next, we provide a new function, and then we go in and change out the first instruction in the thing that gets called. to jump to our program where we then save off the registers and do the activity that we want. So a lot of the way that AppV would work would be that it would come in, it would then jump into our function, and our function would say, oh, is this a virtual process I care about? And oh, do I have that registry value in the AppV stuff instead? And if so, it would just return that back up. And if not, it would then jump back to the regular function and get it off of the regular Windows registry. Okay, so that's kind of the old school way of doing things. But we had problems. Go ahead and click. We've got lots of people that want to write these things. And so someone else adds in, and so they've got to kind of do a double hop here with this thing in, and that's usually okay until somebody comes in and says, oh, I want to pull mine out. That usually resulted in a blue screen. So in the XP timeframe, Microsoft decided to start doing something about that. And so we now have what are called filter drivers. Go ahead and click next. So this is kind of the new school way of doing it, where the application comes in and Microsoft provides an API for the developers to hook into those special places. And so they don't do any changes to the kernel themselves. They make a call that Microsoft then controls and creates a filter driver list of people to be called in what order they're supposed to come in. Go ahead and click next. Okay. So to help make this work, they came up with an idea of what they call altitudes to help devise what order things get called in. And so the higher your altitude number, the earlier in that process you're going to be called. And that becomes important. This is off of a Microsoft document that describes the broad ranges of drivers and altitudes that you can get. And you know, it helps do some things like kind of in the middle of the screen, we can see there's a compression area and there's an encryption area. And that's because you always, if you're going to be doing both of those things, you always want to compress first and then encrypt. Because if you encrypted first, your compression would almost be worthless. You'd end up with about the same size data after encryption. So always want to go in that order. And that's kind of what helps with this. And this becomes important sometimes as we're trying to debug AppV. Go ahead and next. This is a link to a page. Oh, I didn't check to see if I have internet set up. Shoot. So we might not get there. But this actually shows the altitudes for everyone that's registered. So when someone writes a filter driver, they're supposed to contact Microsoft and tell them what it is that they're doing, and Microsoft will assign them an altitude number. Okay? So if you have internet, that link will get you there. So we'll skip that. Okay, so maybe we want to try to take a look at how these things are, because my Procmon, one of the things that I always want to do is I would like my Procmon to be running at as high of level as possible. I want it to show me what the application asks for, not what other people changed it in the way of the requests. One way that I've done this for a long time, because the documentation wasn't so great, was to install the Windows debugging tools for Windows, to load the livekd from sysinternals, start up livekd, and I'd run these two commands to load a special thing in there, and then I would do -filters, and I'd get the answer. Turns out it's a little easier. Click next. There's a command. It's in the operating system called fltmc. In fact, Microsoft documented that command for us. It was great. But they documented it in Windows 2000, and they forgot to tell us afterwards that now that you got Vista and above, you have to run it in a command prompt with run as administrator, or it won't work. So I never could get the thing to work, so I always did it this way. And now I know I can just do it this way. When I do, I get results kind of like this. I can see the filter drivers that are in there, and I can see their altitude, and I can kind of figure out where things are going. Okay, hit next. Now, if I do that on a system, this is a trace there from the system that had both the AppV46 SP2 client and the AppV50 client installed. I also had run Procmon, so its driver was here in the mix. And we can kind of see that starting at the top is the top of the altitude. So the AppV4 drivers were very high up. We next have an AppV driver there. That's the AppV VFS driver, which is the first of the 5.0 drivers. Procmon filled in just underneath that. And then we've got the Microsoft anti-malware drivers come in just below that level. The UAC, LUA FV there is the UAC prompt stuff that comes in sometimes from a file system. But we've got another appv driver in there, appv stream, just above that. That I missed. And then we've got the file info, which is basically superfetch and ready boot and stuff like that. So the monitoring of activities came in. And then there's one more appv driver, pretty far down the list there, the appv VE Manager. That one I'm still trying to figure out what it does. But we've actually learned a lot with working with it. But you notice the Procmon filter is happening after the appv VFS. Now, in appv 4.6, the work that we were doing with rebooting and making sure we run Procmon first and then the appv stuff was because Procmon and the appv 4 drivers were trying to load at the same altitude. And so which one got there first caused the other one to get bumped. So that's why we were kind of doing that stuff. At one point, Mark Rusinovich added a feature to Procmon called /external capture that we were using to force that change. That actually seems to have been removed at some point, too. It doesn't seem to have any impact now, and they do things a little bit differently. But this does affect my tracing, and I found a way to fix it. OK. Do we have another slide? Yeah, we go straight into a demo, right? OK, cool. So first we'll go on to our demo system. We'll take a look at FLTMC to see what we have on there. We did run a Procmon, so we'll see Procmon up in there. Okay, so we can see we got the appv VFS driver at the top, and then Procmon, the appv streaming driver, the UAC one, the file info. I've disabled the malware service on here, so we're not having that driver. And then the appv VE Manager down at the bottom. Okay, what we can do, go ahead and regedit, Pat, is I found out how I can force Procmon to load at different places. Right? So when Procmon gets loaded in, it creates, we're using version 2.3, so we get this instances and the Procmon 23 instance thing, all right? And it creates this thing called altitude. It also creates the one there that's called flags. The other ones I created, which is just my own documentation for the demo. Altitude will get set to that 38,520, which is its registered altitude. And we can modify this. Now, if you just go in, like you see here, and modify it, save it off, reboot, Procmon will come in and it will delete this key and recreate everything and start itself at 38 to 50 again. So instead, what I do is I lock it down. So right-click properties or permissions, right? Hit the advanced. And then I've added in some deny rules to keep anybody from actually changing this out. So I add those 3 rules in, and it solves the problem for me after I've changed it. Now, I currently have it locked down, so we need to remove the deny on users. That'll allow me to do the edit. And let's change that to the high level, 406.100, which puts me above the appv VFS now. It gets me closer to the application. Okay, go back to my permissions, hit advanced, click on the allow for users, and edit. And I want to set a deny on set value and delete. And that propagates down. So it keeps it from deleting the key or changing the value on me. Okay. Having done that, I can now reboot. And now when I run Procmon, it's actually going to come in at a higher level filter. OK, while that's rebooting, let's go back to the slide. Question? Yeah.
Do you plan to automate this process in your EPI Manage just above it? Nice.
That's not a bad idea.
With set ACL, maybe?
Yeah. I don't think I've ever tried to set permissions on a registry programmatically, but it can't be that hard.
No, you can try with set ACL from Procmon.
Ah, there you go. Yeah, we are, because what we're going to do next is we're actually going to, now that we've raised the Procmon up, we're actually going to look at a different problem. So this is a different package. It's Winzip, our favorite friend. So in the past, we had this Q drive, and we had this best practice from Microsoft that said that when you install the application, you want to install it into the folder that you named. If you didn't, that would be what we refer to as a VFS install. That's a practice I stopped using a while ago, and we went to app v5. They kind of changed things. We got rid of the Q drive, but they have what they call the primary virtual application directory, which is the same thing. Where are you going to install this thing into? App v5 is so different that the application really doesn't even know about the PVAD when you get into the actual app. So it's really not that important that we install into that PVAD, except for a couple of situations. Primarily, if we're doing connection groups, then we want to install into the PVAD. This particular package, however, it turns out, if you let it be a VFS install, when you try to run the application, you will get this error. Okay? If we did it into the PVAD, we wouldn't get this error. So I wanted to use Procmon to try to figure out what was going on. So let's go ahead. That should be booted by now, right? Okay. How's our time? When do we end? 11:40. From now, you're saying? Yeah. Okay, 28, so that'll be 30, that'll be 50, 12:50. Okay, we're good. Oh, I'm sorry, you're waiting for me? Yeah, so first we will want to go ahead and publish the Winzip, the broken one, which would be the VFS one, right? One there. Add that in. It doesn't matter if you publish globally or to the user. Okay. And now, okay, so there's the error. Great. Why don't you go ahead and close EPI Manage. Let's start up Procmon. Okay. So let's get rid of the checkboxes there. And let's just check our altitude on that. Let's do the command prompt as an administrator. And FLTMC, and then we can see Procmon is now at the top of the list, right? So that's the idea. We can move where that is and change our monitoring behavior. Now we can go ahead and, actually, you've already run the test? I wasn't really paying attention. No. Okay, so yeah, go ahead and clear out those events and run the test, and we can get our capture to help us figure out what's going on there. I'm not going to go through the detailed process on troubleshooting this one, but this is the concept, right? And in fact, what I would like to do is talk about some of the things that I've been doing with this. I've been using this as a way to try to figure out the way that the app vFilter drivers are actually working in there. And I'm getting to the point of getting some good information. So I've taken some applications that are kind of standard applications that are very, very simple. Also some things that I wrote, so I know exactly what that code is doing in the application, and made the calls. And I would do a trace with Procmon at the level we're running now, at the highest level, before the app VFS. I do a trace at that next level down, and I can now understand what impact and what functionality is contained in that driver. And I'm starting to understand app V better, so the target thing I'm trying to figure out. I also am getting better at now being able to look at my Procmon trace and understand probably what's happening here by understanding patterns. Because a simple call of the application saying, I want to open this particular file in the package, can blow out in a standard level Procmon trace into about 8 entries just to open a file to read. Okay? And I'm now getting to the point where I'm starting to recognize those patterns when I look at that. Why don't we go to the PDF file, which should be off of our desktop. So I've got a couple of PDFs. Eventually, I'll be publishing some of this information out. We've got some more work to do on this. And no, we want to go to Oh, right, we resized our screen, so everything moved. Publish issues, maybe? No, I'm sorry, yeah, you're on the wrong system. You don't want to be on a client system, you want to be on the one with the PowerPoint, and it'll be a folder that's already open. Yeah, right there. Okay, so why don't you grab type, analysis type. So the type command, that's a DOS command. All it does is open up a text file and display the contents, right? So when yeah, you need to zoom in on that a little bit. Let's get on the upper left-hand corner. So when I open it, you know, what the application is doing is it's first doing a find file to see if the file we referenced in the command line is there. And then it opens it for read purposes. And then eventually it issues a read command. So at top level, you know, this is what I'm seeing in the Procmon trace now. If we scrolled down, we'll see here's the trace that's running now below the VFS driver. We got a lot more calls that are in here that happen as a result. In particular in app v5, one of the funny things I see here is that, so I'm opening a text file which is inside the package. And I think because of the file extension, and I haven't confirmed this yet, what it does is it first copies the file. Even though I'm opening it for read purpose, it makes a copy of the text file and places it in the user app data local folder, and then opens that up for read. Now, I'm assuming they're doing it on the basis it's a text file, therefore it's something I might change, and that should get, you know, cached over there. But the call was just for a read. It was kind of stupid to do it there. But that seems to be what they're doing, and it matches a behavior I've been seeing in AppV, where I would run things and I'd find things getting put out into the user's profile area there that I couldn't figure out why. And I think this is why. All right. So, so I did this. I put it at a lower level. We get a few more calls. Right? So one of the things that ends up happening when you're opening up files, now, once we get below that VFS level, it has to check. Not only does it look for it inside the package, it first has to check to see, do you have a cached copy? So even if you do not have the copying scenario, it's still doing kind of double checks for the create command, which is the open in there. But once we get below the AppV VFS, the other layers are fairly consistent. The big difference is that the streaming layer is responsible for actually streaming things from the original source. So wherever you said you published it, if it hasn't been cached locally, it comes from that streaming source. So the call kind of comes down, hits the AppV streaming driver, and from there the AppV client executable, it's a separate piece, gets notified, and it actually streams things in and then goes back up the stack. All right. But what we do get down there are what are called reparse points on the disk. So if you've been in AppV5 and you publish something out, you can go to the program data folder, Microsoft, AppV, follow GUIDs, and you can actually see all of the files in your package. Even when you're running in the cacherless mode like I am here, you can see the footprint of all of the files. You'll have the icon will have a little X over. In fact, why don't you do that while I'm talking on the client machine? The files will have a little X over them to indicate that it's not fully there. If you right-click on the file, you can see how much is on disk and what the full size is, so you can get an idea of how much of that file is cached. Well, the way that that works is that there is a file getting placed on the system. Now, files can have attributes, extended attributes, and reparse points. So attributes are things like, hey, it's read-only, right? Extended attributes get you other things such as digital signatures, ACLs, and things like that. But a reparse point is something that says, hey, this file isn't really here, it's somewhere else. It doesn't really tell you where it is, it just says it's somewhere else. And the assumption is that there is a filter driver somewhere in the chain that will process the reparse. And as I go through these tracings, that's what we see happening. Okay? We see it come down, it finds the reparse, that bubbles up to the appropriate level, which would be the streaming driver, and then the streaming driver says, oh yeah, I got that for you, on the basis of having seen that reparse point. Okay, and you'll see that show up in Procmon traces sometimes. You'll see things actually look for a reparse point. All right, where are we? Oh, actually, you know, this has got an AppV client too. You can go to program data there. No, right there. Oh, okay. You can open a new one too. And see. Program data. App V. Just pick any of the packages there. And you see, this is what I was talking about, where the files are kind of shown there. If you hit root, this is where the files of the package actually get displayed out. Double click on root. There we go. We had, in this case, this was that ATM package, so it really has an exe and an icon. It's a pretty simple package. And it looks like those are probably there. Why don't you right-click on the exe, ask for properties. Okay. And that one's fully cached. Oh, that's right, because this isn't my client system. This one actually has the caching turned off, so it's been fully cached. Okay, but that's what we would see if it wasn't fully. If the file hadn't been fully cached, we'd see a difference in those sizes. All right, so let's go back to the PowerPoint. Okay. See where we're at there. We did that one. Okay, and that's actually the demo we just ran into where we did the layering. So this is kind of the way that I like to think about Procmon now, is that I can come in, I can inject that filter at the layer that I want to see. And whether I'm dealing with AppV or I'm dealing with some of the other vendors out there that are doing stuff, whether it's user profile stuff, Kevin Goodman's new company, the next thing I want to do is I want to get his stuff installed so I can see where his filter driver fits in, because that's what they're doing, right? Really can understand and maybe help debug some of those problems, because you really want to be filtering at the right layer when you do this. So now you know how. But this doesn't always solve all my problems. There's still a bunch of apps I have problems with, and we have yet another tool we can go to. Go ahead and click next, Patrick. The way I like to describe this is what I really want to do is I want to be able to view through all of those layers at once. I don't want to look at just one layer at a time and have a piecemeal piece. I want to look at them all. And there's a right tool to do that. Go ahead and click. I describe it as kind of a kaleidoscope. And I use this to kind of change the range of the area around the ground that I'm looking down on. And then I can turn that dial and sort of filter in on what I want to look at. So I get two different ways to do that. And it's a pretty good tool for that. It's called XPerf, would be the generic name for it. It's a little more complicated to use, but it can be very powerful. I think we go to demo now. Oh, first we talk about how you get this stuff. So you get this, it's part of the Windows Software Developer Kit, is one way to get it. But what you're looking for is the Windows Performance Toolkit, which is one item that's in there. You don't need the other pieces. So you can get that from the SDK, or click Next. You can also get it from the ADK. And the ADK seems to be a little bit newer, although strangely, if I only pick the component of the Windows Performance Toolkit, the other one seems to be bigger. So I've been using that one, the first one, only because it's bigger. I figured bigger's better, right? It's got to have more stuff in it. So that's what I've been doing. But basically, you just install that thing. Go ahead and click Next. And then we can use that as a monitoring tool as well. Okay. One of the things I wanted to use the tool for was to try to figure out what the impact of superfetch was with AppV now. Does it get involved? I don't know. We're running it on client desktops. You might have superfetch on. So I wanted to figure that out. And this was helpful. This was also helpful for the Winzip problem. Ultimately, I ended up having to go to XPerf to do this. So we'll go ahead and we'll try something and see if we can take a look at that. So I think we go to a demo? Yeah. Let's go to our demo system. So once you've installed it, you just go to the Start menu and find it there under the Windows kits. So we'll start. So there's two pieces to it. There's an analyzer and a recorder. It's highly customizable. We'll start with the recorder, right? That's the equivalent part of Procmon that's going to say, hey, I want to get the capture. But what it does is it allows you to pull anything that's available from the event traces, right? So you can get anything that Windows has available to it. as well as any other vendors. If they're using ETW, you can trace it in here. So you can capture all of that stuff all at once. So what I do is I always want to start out with file, registry, and networking activity. Those are kind of the three. Maybe you don't need the networking activity. But then if Patrick would hit add profiles, you can customize your own profiles. So I've done this, and I will end up publishing this out. I have a profile file here that brings in all of the AppV ETW stuff into this trace. Okay? It's just an XML file that lists the things out is basically what that profile file is. So I add that in. Now, we can log in different modes. This tool is used heavily by folks that are writing device drivers and want to look at their boot time performance, because they can actually go into the mode there and go into a boot scenario, and it'll actually reboot and start the tracing extremely early in the boot process before the drivers for the boot time drivers get loaded. This thing gets loaded first, so you get a full trace kind of thing. But I normally just leave that at general. The level can be verbose or light. I just usually leave it light. And we can log to memory or to disk. If you're doing something that's an extremely verbose and long trace, you need to go to disk, because you'll run out of space, and it treats the memory as a circular buffer, so you'll lose the old stuff. But if you're just doing something small, memory is fine, as long as you got enough memory in your machine. And that's the way I prefer to go, because I don't want those writes going back out that I then have to try to ignore. All right, so we do that. We hit the start button. And then we do something. Yeah, let's run Winzip again. OK, boom, failure happened. Let's hit the save. All right, we'll add some type of description. Oh, that's the other thing I forgot to talk about with Procmon. With Procmon, as well as with this, what you really want to be doing is saving stuff out to files when you run a test. So in Procmon, you just go File, Save. It creates a file called a PML. No matter how you are filtering, you have a choice at that point of saving only the stuff that you have currently displayed or the entire file. I always just save off the entire file. Typically, in a Procmon scenario, I go through, I see some stuff, I get some ideas, I then want to go try it. If that doesn't work, I really want to be able to come back to that Procmon trace, open it back up, and take a look at where I was and start looking a little bit further, rather than have to rerun the whole test and get a new trace. OK, so we did that. I've got some traces here. Now it moved. Top of the screen, second column, is the trace file. That one right there. That's one I did earlier. Okay. And this is the interface that you get to do the viewing. And this is where the kaleidoscope comes in. So we've got a number of things here on the left that we can drag out. I usually pull out that processes one. Just double click on processes or drag it to the right. Either way works. Okay. And that shows me when processes start and stopped, which gives you a nice timeline to work off of. Also want to open up the processes one, the system activity, sorry. I want to pull, there it is, generic events. So this is where all that AppV stuff that I said I brought in, that's where those traces are going to come in. And then I usually want to see the file I/O, which is under storage. And I like to see it typically by process as well. OK, so activity by process. OK, so I've got these up, and these are all time synced. So as I zoom and scroll around, I get them all. Now, this particular problem, remember, we launched Winzip, we got this error dialog. When the error dialog happened, we got a Windows ding that happened, right? So those are always .wav files. So to find out where the problem happened, I can find the WAV file and start working backward from there. So we're going to go into the file I/O. And I'm going to ask Patrick to hit that second button there, which puts me in table mode. So I'm getting graphs, but all the detail is behind it. And if he now scrolls over to the right, now we got the wrong one, because this one doesn't have it. And this is the wrong file I/O. Do the pull down to the right of where it says file I/O, where it says activity by process, thread, and type. I meant over here. You can actually change it here. Just that little down arrow. Would have thought that would be the one I want. Why didn't you have a scroll bar, Patrick? How about try the count? Let's see if we get it there. No, we must have the wrong graph. Let's look at it over there.
Are you sure we don't want generic events?
No, we don't want generic events. We want the file path column. Open up disk usage. Maybe that's where we're supposed to be. Nope. Try clicking in the column area with a right click. No, down below in the column area. And let's see if we can add the column in. Is there a file? Yes, there is a file name column. Try this scroll bar. Maybe we're just not seeing the horizontal scroll bar. Yeah, there we go. There we go. It's always a challenge when the screen sizes change on you on your demo. All right, so he goes in the file name, he right-clicks, does find in column, asks for .wav. So he's going to find the first instance of a file name ending in that. And now he scrolls down a little. Okay, there we are, critical stop. Now, by clicking on this line now, we're getting this little blue line. I don't know how well that's showing up. That's showing exactly when that time happened. So now I want to just grab an area here, just right of it, go a little bit to the left, probably to the left of that diamond. Yeah, there. Now, a little more left to the next open diamond. Right there. And you can right click and zoom. And it basically excludes all of the data outside my zoom area from the display on all of the different charts here. So I can kind of start to narrow in on where the problem is. We come in here now into the generic events. If you would make that series column a little bit bigger, Patrick, we can see the full names on those. Okay. All right. So I might want to be coming in here and taking a look at, let's see, in this case we were running an application. Normally I would have done this with the publishing problem, and so I'd be looking for the publishing category that's in there. Where we're running the application, the AppV ones are not all that significant necessarily, but this is kind of the method that we use, right? We can zoom in on an area, look at different kinds of activities to figure out where the problem is, and it's all time synced for us. And I find this to be much more helpful if you get into a deep, heavy problem. I'm looking forward to going back. We've been having a problem with several of the versions of AutoCAD with AppV lately, where they've made some type of change and it's just incompatible with AppV. And it's weird. Some versions of AutoCAD have the problem and some don't. And we have not been able to crack this problem. I've been working on it for almost a year now, on and off, for a couple of customers. And I haven't taken it to this level, and this is what I really need to do next. Particularly now that I know more about how the AppV5 system was working, because we were dealing with AppV4. And now with AppV5, I think I can probably get a little better visibility as to what's happening on that problem. All right, what do we got left in the way of slides, Patrick? Because we've got to be getting close.
4 minutes, 30 seconds.
4 minutes, 30 seconds. I'll talk really fast. Okay, what else do we have? Oh, I have 10 minutes. Wonderful. Okay, so let me talk about superfetch. Okay, and what happens? Remember I talked about the reparse points? Okay, so what happens with superfetch in AppV? If I use the client cacherless mode, if you remember when I talked about the filter driver levels, the superfetch monitor driver was down below the AppV streaming one. So if I set up in a cacherless mode, the only thing that thing ever sees is the reparse footprints. Okay, and that's what it monitors and detects and puts into its logging stuff. Why don't you go ahead to the client system and start up that superfetch list. If I do not use the cacherless mode, then the calls come down, it goes to the streaming, it goes out to the client, it streams the stuff in, and it writes it to the disk in addition to sending it up for the application to use. So now those disk writes get noticed. And when the application runs and it's been cached, it's seeing the reads actually come off a disk. So now those things get put into the superfetch information. Okay, so this is another free tool that I have. It's called Superfetch Tree. It's associated with the session that I did last year when we were taking a look at the different ways Microsoft Windows does caching. And there is no good information out there about what Superfetch actually takes and doesn't take. So I wrote this tool which digs through the Superfetch databases and to the best of my ability parses that stuff out and displays it here. And we can actually see the files that are in here. And if he gets down into the C program data area, we'll actually see. Now this is a trace that's on, this is the client itself, so we want to go a lot further down. This is on the system that is set up in the cacherless mode. So what it will notice would be the reparse points. Yeah, just, there we go, program data, app v. And we can see it is noticing activity on all of those files, and it is adding it in, and potentially is attempting to load that when the user logs in again if they use that same application quite a bit, right? That's the idea. So Superfetch does apply to AppV in a cacheful mode. It would be very beneficial. In a cacherless mode, I don't think it really matters if it's on or off, quite frankly. The reparse isn't going to save you. Okay. All right. So we did that. Kind of an overall summary then of my techniques is I really start with EPI Manage as that first place I'm going to use to start looking at the package, see if there's a problem, go to the event logs, watch for that type of activity. If that's not enough, I move into Process Monitor, try to get a trace, see if that's helping me. I don't find Process Monitor as helpful as I used to in years past. And quite frankly, it's because the AppV client has gotten so much better in the sequencer over the years. It used to be that I would find a lot of stuff where it's like, oh, we didn't get this file, or more likely, there was a COM registration that didn't happen. The installer attempted the COM registration and it just silently failed, and I'll see that in the Procmon trace, and I would then go back into the package and just do the reg server 32, that DLL, and it would solve the problem. We don't see that stuff happen much anymore. So I'm not finding as much success out of Procmon, but it's still my next step. I think XPerf is harder to grasp out of the box. I mean, you really need to work with it a while to understand how to effectively do that zooming and get yourself into the right place and what you should be looking at. But ultimately, that's the go-to tool for me these days, if I really have a deep problem. All right, so it sounds like we got about 5 minutes. So we got time for questions.
How do they get your free tools?
Oh, how do I get my free tools? What a great question. I brought a plant, sorry. That's Mary Jane. So Team Urgent is, you're looking at like 3/4 of the company, right? So I'm the kahuna, because originally it was just me, right? So I was just the kahuna. I couldn't be the big kahuna because, that can be kind of weird. There's only one person. And then Mary Jane joined us, and then Patrick joined us, and then last August, my daughter Kate finished college, so she joined us. So it's just the four of us. So where do you get this stuff, right? So our website is www.teamergent.com. That's actually on the next slide, if you want to hit that. Yep. I've got a ton of free tools up there. The EPI Manage tool you saw there, the Superfetch tree thing it's in my performance section, but there's an AppV5 section in there. And I try to make those tools available for the community for free. I've got a new thing that I've been working on the last few months called AppV Self-Service. So those of you who have been around AppV for a long time remember the old SoftGrid zero touch. One way that tool can get used is kind of as a zero touch. So the concept being the two different uses of it. One is I want to have an AppV client. I don't want to have any of the servers. I don't want the AppV server. I don't want config manager. I just want to have an AppV client. And I want something to get the apps on down there. And the one mode that it works is you would tell the tool where the share is for the app v packages, and you'd give it an OU where you put application groups in there. So these group names need to match the name of the packages. It links up and says, oh, is this user or machine a member of that particular group and the package is there? I'll give it to you. So that's one mode. It's kind of the silent mode. The other mode is it uses that method for authentication, but the user gets a little GUI that shows him the packages that are available to him, and he can just click and say, yes, I want this. So it's a sort of more of a self-service model. So that's available up there. Really only, the version currently released only works for desktops and does not handle connection groups. I have a new version that should be coming out in the next couple of weeks that handles RDS and adds in the connection group support. So yeah, it's coming up. So yes.
How about XenApp?
How about XenApp? How about XenApp? I have a tool for XenApp, if you want to talk about tools. Yeah, so if you have XenApp 6.5, not 7, but in 6.5, once you get your app v package onto the system, however you get it, you need to get it into the, I don't want to call it the XenApp console, it has a different name, right? App Center? App Center, right? You want to get an App Center. And particularly with the old app v 4.6, you know, the command was sft tray, and then you had to find an icon for your app, and that, of course, was virtualized, so you don't have an icon. So you have to go do some crap to get that out. This tool actually would allow you to just point to the apps in the app v client and pull them in and do the publishing. So it's an interface that works the same way the App Center one works, except you start with a screen that details out, here are your app v apps. And you just pick the ones you want, and then you pick what the servers are, all the other properties that you want to set, like, you know, single use and encryption and all those crappy things. And then it'll publish it for you. It's called Publish from app v, and it works with both app v4 and app v5 client apps. So it'll pull them both in. Zen Desktop 7, I should say, the new name, right? Citrix has decided to integrate directly with app v. Now, their assumption is you're going to use the app v server, okay? So the process is you have to add it into the app v server first, then you can go to the, it's not the desktop. Yeah, they've got two consoles now, right? It's the one where you configure things. You go to that console, and then it knows about app v through the publishing server. You actually register it with the publishing server, so it knows what the apps are, and you can just pick which ones and add them in that way. That's a pretty effective, but you kind of still have to publish twice. You have to do first in app v and then there. I've been complaining about that to them and saying they should look at what I'm doing and do something similar and build that in there and get rid of that extra server. You really don't need it, right?
There's still a workaround on that.
There is?
Yeah, you could run a command line on the XenApp server, so it would work in a small environment. So let's say somebody has like 5 servers of that, you could just run the add publish command and do a global at the end. That way it will put everything in the program data folder, just like how you would do otherwise, right? And then just publish from the console the exe3 pointing to the program data folder.
Okay, so as long as you're not doing published desktops, so you have people getting access to the wrong apps, that would be a solution. Interesting. So let me get that for the tape as best I can. There is Citrix, I assume this is some Citrix,
Citrix XenApp 6.5.
but they have a published blog or something on this?
I got it from one of the person who's working on the project team.
Okay, so you got it on a private basis. So who knows? It could be in a blog somewhere, or might be in a blog soon. That you can do a command line thing to add the stuff into the machine using the app v client PowerShell commands, and then effectively load up the entire app mix in one shot into the Zen desktop stuff, right? As a way to publish it. Obviously, if you had users coming in and logging in and getting full desktops on the Zen app server, they'd see all of the apps. So that in that case, you'd have a problem. But if you're doing published apps, that works just fine. It's very simple. That was my timer. I'm seeing you stand up.
We do have a networking break and lunch is going to be served, so if you guys have more questions, this is when you guys go to lunch.
Okay. Well, thanks for coming. Hey, we're here all week. You know, feel free to stop by and grab me in the hallway. We can talk more.